Everybody, welcome back to yet another fun and exciting Algebra 2 class. Today we'll be in lesson 11.5. You'll find that on page 533. 11.5, 533. Geometric probability. What is geometric probability? We know what all these other probabilities are. But how about geometric? Well, when you think of geometry, more than likely you think about shapes, squares, circles, rectangles, triangles, things like that. Well, you would be correct in thinking that maybe it has something to do with shapes, probability and shapes kind of combined. And that's exactly what's going on here. I wrote down that this compares length, area, or time, anything that has like any sort of geometric properties. Time doesn't necessarily have geometric properties, but it is measurable. So we're talking about measurable things here. So let's talk about it and let's look at this and see if we can figure it out. Look down here at P event. What is that? What is the P event? Well, P is probability of the event happening. So whatever event we're talking about. Here's the way that we're going to figure this out. We're going to put the area of the successful outcome. The area of the circle, the area of the square, and you're like, wait, what? We got to figure out the area? Yes. You remember how to do that, right? It's only been a few years since pre-algebra. You remember all that stuff. Well, if you don't worry. Look down at that page at the bottom. Table B is there to save the day. Table B, page 533. Look at that. Circle A equals pi r squared. The area of the circle is in diameter as well. The area of the square is side squared. Area of the rectangle is length times width, and the area of the triangle is 1/2 BH. So there you go. Another thing that we're going to have to do is we're going to have to do some conversions. Feet to yards, inches to feet, things like that. The common conversions there on table C will help you in this chapter if you've forgotten. Now, I know if you had me as your teacher in 8th grade, you have not forgotten these. I have faith in you that you still remember these, okay? So maybe not, maybe not. So if you do, great. You don't even need the chart. If you don't, there's your charts right there. So let's go back up here. The area of successful outcomes over the total area of all possible outcomes, all right? So it's the same thing. It's successful on top, total on the bottom. Nothing's changed here in our probability. The only thing that's changed is now we're finding area instead of just using numbers that they give us. All right, here is the example on page 534. You can look down there. It is example 11.5a. I like this example. I think you're going to like it too. I like it because it has to do with food, and I like food. So what are the chances that a leaf will fall on a 9 by 11 rectangular pan of hamburgers that is sitting on a picnic table that measures 6 feet by 29 inches? All right, so the first thing I like to do, you don't have to, it's not a requirement, but the first thing that I like to do is I like to draw a picture, and here are my hamburgers. Doesn't that look yummy? Little blue hamburgers, yum. All right, it says that the pan of hamburgers is 9 inches by 11 inches, 9 by 11, okay? So there's hamburgers inside of that dish. Then it says that the hamburgers are sitting on a picnic table that measures 6 feet. Now, you got to realize that these were in inches. Now we're in feet by 29 inches. So I think the first thing that I would do is I would figure out the area of all of these different shapes. So we can look down there and we can talk about what's the area of a rectangle. The area of a rectangle is LW, length times width. And these are both rectangles, so we'll use that same formula. And this one's the easy one. We just 9 times 11 is 99. So I'm going to put the hamburgers. I'm not going to put it inside there. I'm going to put it over here. Hamburgers equals 99 inches squared. Now remember, it's area, so we have to do squared because we multiplied inches times inches and it gave us square inches. Now, this here is a problem. 6 feet. We need to convert that to inches. Remember this? Okay, larger to smaller, multiply. Some of you are like, oh my goodness, I remember that. Okay, and so feet are smaller, feet are bigger than inches, and so we're going from larger to smaller, multiply. 6 times, what's our conversion factor? It's 12. What's 6 times 12? 72. So let's just go ahead and change this out. Instead of 6 feet, we are going to write 72 inches. So 72 inches. Okay? And now we can calculate this in inches, then everything that we're doing is in inches instead of having feet measurement in there. So again, length times width. You're probably going to need your calculator for this one. I know I sure do. 72 times 29. Equals 2,088. So the area of the table equals 2,088. And that is inches squared because we converted it to inches. All right, so now the leaf is falling down from the sky, falling down, it's blowing around, okay? And it's going to land somewhere on the table. This is not taking into account that potentially the leaf could fall on the ground. There's a 100% chance that the leaf is going to land on the table. This is just for our example. That's not reality, but that's for our example. So leaf is falling down. What are the chances it's going to land in the hamburgers? That would be tragic, wouldn't it? Wouldn't you hate to get a leaf on your hamburger? I would. But anyways, what are the chances? Well, here's what we're going to do. The desired area, and sometimes it's not desired. Like, it's not desired that the leaf lands in the hamburger. Okay, nobody wants that to happen. Nobody wants a leaf on their hamburger. But in this case, we're still calling it the desired because that is what we're looking for. We're looking for those chances. So we're looking for that. That's the successful outcome. All right, so we'd put 99 over 2,088. Not 20,000, let's go 2,088. All right. And what we want to do now is we want to just go ahead and divide that. And technically it is inches squared and inches squared, but that's going to cancel when we divide. So, and it's going to come out with 99 divided by 2088. 99 divided by 2088 equals, that is 0.47. 0.47. 0.047, sorry. 0.047, there we go. So there is a 4.7% chance that that is going to happen. Okay, so the chances are that it's going to land on the table and not in the hamburgers. But there is a 4.7% chance that it would land in the hamburgers. All right, so that is a single event. There's one thing that can happen. It can either land in the hamburgers or it can land on the table. So it's just a single event possibility. Now imagine, let's go to the next page. Page is number 535. Now imagine that the table has 3 containers on it. There is a round salad bowl with an 11-inch diameter. So let's go back and let's draw that. 11-inch salad bowl. So I'll draw it nice and pretty. I'll draw a circle. And so we'll put the salad bowl right there. And it has an 11-inch diameter. So let's draw the diameter through it. And that's 11 inches. Okay. Then it also says that there is a 8-inch square dish of beans. All right, so let's draw a little square dish of beans. And it's probably a little bit smaller than that. There we go. And that is 8 inches. Okay, so we'll call that 8. And those are inches, and the salad bowl is inches too. Its diameter is in inches. So everything's in inches still. We already have the hamburgers right there, 99. We already have the table, 2088. So now what we need to do is we need to find the salad dish and the square. So the salad dish we'll do first. If you need to know how to do that, it's pi r squared. So pi r squared. The radius is going to be 5.5 since the diameter is 11. So it's pi times 5.5 squared. So let's go to our calculator and do that. And we get 95.03. So the round dish, and we'll call this the salad. Let me erase this real quick. So our salad dish equals 95.03. And that's square inches. All right, now we want to do the beans. Beans equal what? Well, 8 times 8 is the way that you figure that out. So I don't even need my calculator for that. We got 64 inches squared on the beans. Okay, so there we go. There's all of our different things that are on the table. So now what do we need to do? Now we need to start answering some of these questions. What is the probability that the leaf falls into any of the containers? Okay, so if it falls into the hamburgers, good. If it falls into the beans, good. If it falls into the salad, good. If it falls onto the table, not good. All right, so we're going to put our desired on top, and then so that would be the beans, the salad, and the hamburgers added together. The bottom is going to be our 2088. Let's go back up and add those other ones together. So hamburgers were 99. The salad, we'll just round the salad to 95. It'll be fine. 95 plus 64 equals 258. So 258 is our desired. So it could land in anything. We'd be fine with it. And this is square inches and square inches, but obviously that's going to cancel again, so we don't necessarily need to write that. So 258 divided by 2088 divided by 2088 equals, and this is 1235 or 1234.124. 124. And then we could move our decimal 2 spots, and we would get 12.4% chance on that one. 12.4. If you're wondering where I am on page 535 on this. Actually, 530. Yes, 535. I was right. Near the bottom of the page. Okay, so that's a 12.4. Now, I've just added some other questions that really kind of go to, there's no example for this in the book, but let's talk about these. What is the probability that the leaf falls onto the table? Interesting. Now we want to know if it falls onto the table, but we have a problem. Now, here's our problem. The table is actually, okay. So let's go back to this. The table is in yellow. Okay. Now, if it falls here, that's bad. If it falls here, that's bad. If it falls here, that's bad. What we want is it falling onto the table. So we've got to think about this. What we need to do is we need to take the total table, which is the 2088, and we need to subtract the burgers, the salad, and the beans. And that will give us how much space is desired over the total space. So if we take 2088 minus our 258, what's our 258? Well, that's our burgers, our salad, and our beans combined. And that's going to give us what? I don't know. 2088 minus our 258. And that gives us 1,830. So 1,830 is the desired, because that is our total table minus the bad ones that we don't want it to fall in. So the desired is 1,830 over the total table, which is the 2088. All right, and so we would go ahead and divide that out. So 1830 divided by our 2088. And that gives us an 87.6, 0.876, 87.6% chance. Wow. Big chances. It's probably going to fall on the table. It's probably not going to fall into the beans, the hamburgers, or the salad. All right, last one. What is the probability that the leaf falls into the beans or the hamburgers? Do you remember how to do this? Okay, so what we need to do here is we need to take the beans and add them to the hamburgers. And we're not going to take all of them together. We're just going to take the beans and the hamburgers. And so the beans, that was 64, and the hamburgers was 99. So that's going to be 163 is going to be our total there. 163 is our desired. And still the table is the total, which is 2088. So what are the chances that it could fall into the beans or the hamburgers? 163 divided by our 2088. And that equals 0.078, 0.078 or 7.8% chance that it falls into one of those. Okay, so again, this is the same thing as we've been doing with probability, except for now we're using geometric shapes, and we have to calculate, we have to convert, we have to do all those things. Same thing with time. Time, you would just convert to one measurement of time. If, let's say, it's in hours and minutes, you would just convert it to all minutes. If it's in days and hours, you could convert it to all days or all hours. You can go either way on the conversion. Typically, it's easier to convert to the smaller measurement because then you're not dealing with fractions. It just gives you a whole number. The whole numbers are usually pretty big, like this 2088, but it doesn't matter. We have a calculator to use, so no problem there. Okay, well, that's it for this lesson. I hope you learned something. If you missed anything, go ahead and slide it back and take another look at it. We'll see you later. Have a good one. Bye-bye.